It's recording. All right, here we go. Woohoo! Today's date, 2/9/21. So today, our objective really is graphing polynomials with zeros and end behavior. All right, write that down. Figure out what the heck I'm talking about, okay? Graphing polynomials with zeros and end behavior. So we're going to graph these without a calculator. We just have to get the general shape. We don't have to have perfect, but we need the general shape so we understand what's going on. So here's what I know. Let's just take a look. Degree 2, some kind of x squared. It could look something like this, okay? Could. Doesn't mean it will. I mean, sometimes they're upside down. Sometimes this could be shifted up. Sometimes this could be shifted down, okay? But that's a general shape, okay? Degree 3, some x cubed. Could, again, I'm going to say could look like this. Okay, this is a general shape. Okay, that's an x cubed. And hopefully you're going to see a pattern between all these polynomial graphs, okay? Degree 4. Hopefully you kind of got an idea. And again, an x to the fourth equation. Could look something like this, okay? Like a W. That's just a general shape. And it doesn't always look like this, but it can, right? And degree 5, I think you're catching on to the idea. Degree 5, some x to the fifth. Could look like this. Okay, could look something like that. And of course, it could be moved up, down. There's lots of variations of this, but this is just a general shape of it, okay? And finally, x to the 6th. I think you're probably catching on. So before I graph this, here's what I know it could look like. It could have 6. It could have 6 x-intercepts, right? So I'm going to go 1, 2, 3, 4, 5, 6. I mean, you see that generalization? If it's got 6, x to the 6 is going to have could have 6 real zeros. So it could look like this, right? And then, you know, the thing goes and so on and so on and so on, okay? There you go. So conclusions. Conclusions. Anybody, what do you guys see? What's some general things you see?
The degree numbers, how many times it goes across the x-axis.
Good. So the degree number is, generally, could have 2 zeros, 3 zeros, 4 zeros. Everybody agree with that? So it could have that many zeros. So the degree, we know the degree is also the number of zeros. And here's something else I want you to see. If it's even, right? If it's an even, then take a look at the even ones. What do you notice about the even ones? They're both going to finish up, right, for end behavior, right? Or if it's negative, they're going to both go down, right? We're going to talk about that also. Now, what about odd? What do you know about odd? Always goes up and down. So end behavior, if it finishes up, it's going to finish down. If it finishes up, it's going to finish down, right? Always, always, always. Good job, Spencer. So let's talk about end behavior. So if it's odd, exactly what you said, okay? So it's even, then as x approaches infinity, y would approach infinity, and as x approaches negative infinity, y would approach negative infinity also, right? Oh, pause infinity. My bad. I did that wrong. Pause infinity. And it is possible the other, okay? But on the odd, as x approaches infinity, y would approach infinity. But as x approaches negative infinity, y would approach negative infinity, okay? Just like Spencer said on the odds, okay? Now.
Wait, I think you just wrote the same thing.
No, I put a pause infinity here.
I didn't see that.
Yeah, that was my mistake. I did make a mistake, so I fixed it. Thanks, Nina, because I did write the same thing twice, but I had to fix it, okay?
How about this
curve. It's in blue. Okay.
Then when I put it in and I press enter, it just says error.
Oh, you might have an I answer, Chloe, right? Did you put a negative in there? Did you put a negative in there?
Yeah.
Okay, so you know the answer's got to be some I, right? Probably. Okay, now let's take a look at this one. So we're going to do it without a calculator. So here's what I know. Okay. I know I'm going to have zeros at -2, +1, and 4. Okay, because we know if we set it equal to 0, right? And we solve. Oh, we did this in geometry. Remember how we did this in geometry? You'd get x equals -2. Okay, that's there. You'd have x equals 1. That's there. And we'd have x equals 4. That's there. Okay. Now, this has got to be a cubic, right? This has got to be some x cubed. Even though I didn't multiply it out, it's going to be an x cubed. Everybody agree? So if it's an x cubed, it has to have this shape right here. So I'm just going to draw it in. I'm going to take and just draw it in. I don't care about y values right now. I just need the general shape, okay? Okay. How's that? If we would have had a negative x cubed, like if one of these had been negative, it would have just been upside down. Does that make sense? If one of these had been, if we'd gotten a negative x cubed, it would have just been upside down. Okay, pretty simple. Let's turn the page, okay? Okay, example 2 has a double root. What does that mean? Well, I'll show you. A double root. All right, let me go ahead and let's find our zeros. So we're going to say, set it equal to 0. Of 0 equals x. So let's find our zeros first, okay? So we'll go 0 equals, oh, it's a negative x. Okay, and 0 equals an x minus 2, but that happens twice. It's going to happen twice because of the quantity squared. So that's where I'm going to get a thing called the double root. So I'm also going to go a 0 equals x minus 2 again, because it happens twice, okay? And then I'm going to get a 0 equals an x plus 1, okay? So far so good. And then I'm going to solve, divide by -1, divide by -1, and I get 1, 0 at 0. Plus 2, I've got x equals 2. Plus 2, I get x equals 2. And -1, x equals 1, okay? Graph paper out to graph this. Let's do number 2. That's number 1. Let's do number 2. Try and graph this. Okay, let's see what I get. So I have zeros. One zero's at 0. The other's at 2. And I get another at 2. And -1. Okay. Okay, this happens. I want to write this. I got to write myself a note to remember, okay? This one happens twice. Okay, so that's a double root. How does that work? Okay. So before I do a whole lot, it is an x to the 4th, right? I know it's an x to the 4th because I've got a x, another x, another x, and an x. So this is definitely some x to the 4th power. Okay, right? X to the 4th power. So it's going to look like x to the 4th. It's going to look like this. Okay, it's going to look like this, except it's going to be upside down. Except this one's going to be upside down. Now, how do I know? Come on, tell me. You guys are smart. How do I know it's going to be upside down? Because it's a negative x. Exactly. If I go negative x times x times x times x, I get a negative x to the 4th. So it's really a negative x to the 4th, right? Okay, if that happens, it's got to be upside down, right? So I'm going to draw it like this. Okay, now this is where you've got to watch. Please watch. Everybody watching, all eyes up here. Okay, I'm going to go up. I'm going to go through this point. But I got to go through it twice. I got to go through this point, but this is a double root. So I go through it and then back down. So it's kind of like a touch and go. So it went through it twice, but then it went through the same point twice, which is kind of like it just touches it, right? And then it's going to look like that and that, okay? That's a double root. It occurs twice in the exact same spot. Weird, huh? That's exactly what happens. Okay. All right, now, let's take a look at example 3. So before I do anything, let's factor. Okay, it says do not use a calculator. I don't need a calculator. I'm smart. So are you. We're brilliant. So the first thing I'm going to do is factor, okay? So f of x is equal to x times an x squared minus a 2x minus an 8, right? Common factored an x. And then I'll go, okay, f of x is equal to x, and I can factor that trinomial. Negative 4, positive 2, right? Negative 4, positive 2. X minus 4, x plus 2. Okay, now I've got that set up so that I can get zeros, right? And the next thing I'll do is just get my zeros. So let's get my zeros. So I'll go 0 equals x. 0 equals x minus 4. And 0 equals x plus 2, right? Solving is easy. That one's already solved. This one's going to be plus 4 plus 4. This one's going to be minus 2 minus 2. So I've got my zeros. Okay, so now I can graph it. Graph paper out. Put some C on there. And again, we're not concerned yet about the y values, okay? Not yet. We will be someday. But right now, all we want to do is just get the shape, okay? So it's going to be a 0, a 4, and a negative 2, right? I know it is an x cubed, and it's a positive x cubed, right? So it's got to look like that one, right? It's a positive x cubed, so it has to look like that one. So I'm just going to sketch it in. Okay, there it is. Now, the last thing I want to do is describe the end behavior, okay? So here's how the end behavior works, okay? So as my x values are going over to infinity, this y value is going to infinity. Does that make sense? Watch my two fingers. As my x values are going, my y value is going to infinity. So we say end behavior, we'll say as x approaches infinity. So as x is approaching infinity, then the y values are also approaching infinity. That's my end behavior. And we say approaches because you cannot get to infinity. I know that seems obvious, but you can't say equals infinity. You never say equals infinity. You can't. You can't get there. How can you ever equal infinity? You can't get there, right? You can approach it, if there's such a thing. And the same thing on the x's on the negative. So as x's approach, because it gets bigger and bigger towards negative infinity, the y's go to a negative infinity. So end behavior, x approaches negative infinity. Y in this case approaches negative infinity. Okay? How's that? Wasn't too bad of a lesson, was it? Okay, so